let's start this part with graphing f of x equals x squared. We know it's going to be a parabola, but we're going to graph it using a table of values. And just like we said yesterday, for our x values, we're going to pick some negative numbers, we're going to pick some positive numbers, but we're also going to pick 0. So -2, -1, 0, 1, 2. So if y is x squared, when x is -2, what's y? 4. And at -1, right? And 0, 0, 1, and 4. Okay, so I go to -2, and it's up 4, -1, 1, 0, 0, 1, 1, 2, 4. Now, this is not an absolute value graph, so it's not going to be a corner at the bottom. There has to be a little curve, right? Make sure you show that. What I like to do is I do that curve first, and then I extend, just so, you know, I make sure it's not like a straight corner. Okay? So that's how the parabola looks. And you can put arrows at the end, or you don't have to. That's up to you. Okay? Now, okay, so this point, this point here is also called the vertex of the parabola. Now notice, when you take the parabola and you split it vertically down the center, it's symmetric, right? Both sides are symmetric to each other. So then that means to graph, all you need is points either on the left side or on the right side, and then you can mimic. Let me do this and then I'll take a question. Oh, I thought you were sorry. Okay, so all you need is either like the left 2 points or the right 2 points, and then you can just like mirror them. So take a look at what we're going to do here. The parabola, right, the function f of x equals x squared, it's a squaring function, right? So from the vertex, if I go over 1 unit, I go up 1 squared, which is how much? 1. Now, from the vertex, if I go over 2 units, then I would go up 2 squared, which is 4. Yeah. Right? Exactly. So if I go over 3, then I would go up 9. And if I go over 4, then I would go up 16, and so on. So that's how we can graph a parabola more efficiently if we don't want to do the table of values. So why don't we go ahead and do that here. So now we're going to do some transformations though. Take a look at this one, x squared minus 5. Where does that move the parabola? Down 5. So where would the vertex be now? 0, comma, -5. So I go to 0, -5, and I put my dot there, my vertex. Now, if I go over 1 unit, I should go up how much? 1. From the vertex, if I go over 2 units, how much should I go up? 2 or 4? 4, because we're squaring, right? Now that you have that, now you can just mirror the points on the opposite side. So mirror that point there, and then I can graph my parabola. Do you see that? Okay. All right. Where does the 4 move that parabola? Up 4. So what's the new vertex? 0, comma, 4. So I go up to 4. Over 1, up 1. Over 1, up 1. Over 2, up how much? 4. 1, 2, 3, 4. Remember, it's always from the vertex, right? And then mirror that way. Okay? Graph your parabola like that. Questions? Okay. This one, where does that 4 move the parabola? To the right 4. So what's the new vertex now? 4, comma, 0. So I go to 4, put my vertex. Okay. I go over 1, up 1. Over 2, up 4. Now I'm going to mirror to the other side, right? Remember, the line of symmetry is at the vertex. So I want to mirror it around that line of symmetry. Okay, you don't have to put the, what do you call it? That dashed line. It's just there to show you guys. All right, so here's 1, 2. Now, what if you forget how to do this? What can you always fall back on? The table. Now, if you wanted to do a table, however, okay, you should always pick the vertex point for x. So here x is 4. And then pick points around the 4. So for example, I would either pick 5 or 6. I mean 5 and 6, those two, and then mirror. Or I would pick points on this side, so 3 and 2, and mirror. Okay? It's enough to just pick the vertex and 2 other points, and then you can mirror them. Does that make sense? Okay. So here, where does the vertex go? What's the vertex here? -6, 0. So here, I go up 1, over 1. I'm sorry, over 2, up 4. Mirror. Okay. And here. Okay, so do you see how, any questions? Okay, do you see how at this point, like before when you were younger, right? It was all about like these mundane like calculations and, you know, just getting things precise. But do you see how right now we're able to step back? We can do this without having to, you know, like routinely plug things into values and stuff like that. But at the same time, look at how precise of a parabola I can still make it, right? So that's what we do in Algebra 2, right? We can step back, we can still be precise, but also more swift. Okay, now here we have a different situation. The 2 here is a vertical dilation, right? Is this a stretch or a compression? It's a vertical stretch, so would that make the parabola narrower or wider? Narrower. So what's the vertex now? 0, 0. It hasn't moved anywhere. So now, from there, if I go over 1, previously I would go up 1. But now it's multiplied by 2, so I go up 2. And if I go over 2, how much would I go up now? 8. I would have gone up 4, but now it's 4 times 2, 8. Okay, mirror this way, mirror here, and look at how cute that parabola looks now. Right? Okay. Questions? All right, questions? Okay, so here, vertex is 0, 0. Okay. Now, right. Okay, so now if I go over 1, I would have gone up 1, but now I have to go a quarter, so I have to go up a quarter. But that's so hard to do, right? So then I say to myself, why don't I go over to the next point? Because I don't know where a quarter is, and I want to be somewhat precise. Okay, why don't I go over to the next point? If I go over 2, I should have gone up 4, but now I go up how much? 1, because it's a quarter of, right? So I go over 2. Instead of going up 4, now I only go up 1.
But I thought you did the thing where you go up 1 and just
Yeah,
slide 4.
Yeah, up 1.
Okay, so normally if I went over 1, I would have gone up 1 squared, right? But now it'll be 1 squared times a quarter, so it'll be a quarter. But if I go over 2, I should have gone up 4, but now it's 1/4 times that, so it's just 1. Okay? And then if I go over 3, then how much should I go up? If I go over 3, normally I would have gone up how much? 9. Now it should be, if it's 1/4 that, then it's like 9 over 4, right? Which is I don't know what that number is. So I don't have to put that number. Usually 3 points total is enough. Okay, so when I graph this now, look at how it looks. Do you see how much wider that made it? Okay, now, if this doesn't mesh with you, what else can you do? Just pick points. Okay, so it'll be 1/4 -2 squared, you get a 1. Okay? 1/4 times 0 is 0. 1/4 times 2 squared, you get a 1. You could always fall back on that. Okay? Okay, next, what does that negative do? It's a reflection around the x-axis. So, what's the vertex? 0, 0. Okay, here. Okay, now, if I go over 1, where would I go vertically? Down, how much? 1. If I go over 2, where would I go vertically? Up or down? Down, how much? 4. And then mirror this way and this way. Okay? All right. Here, where is the new vertex going to be? -3 and -5, right? I move to the left and down. Here. Okay. There is a negative, which means it's a reflection on the x-axis. It's going to face down. The half, right? That's going to change things as well. So if I go over 1, how much should I go down for this one? A half. Before I would go down 1, but now I go a half. If I go over 2, how much should I go down for this one? 2. So it looks like this. Okay, now. Let's talk about one other thing, and then I want to talk about domain and range. Okay, because I know we love domain and range. Okay, so take a look at, this is a summary of transformations then. Look at the absolute value function. Look at the quadratic function. Do you see how they're the same when it comes to their transformations? Right? The plus or minus is the same effect. The A is the same effect, a vertical stretch or a compression. H and K, same effect, moves it to the left or to the right. It's important that you recognize this form because this form is going to be the same whether we're graphing cubic functions, logarithm functions, exponential functions, like whatever you can think of, okay? Now, let's talk about domain and range. Okay. Let's just do domain, right? What is the domain here? All real numbers. Okay. So we graphed parabolas over 2 pages today, right? So here's my question to you. Find a parabola where the domain is not all real numbers. Find which parabola has a domain that is not all real numbers. None of them. That was a trick question. Because all parabolas have a domain of what then? All real numbers. So that's like almost like very little thinking, okay? All parabolas have a domain of all real numbers. What about the absolute value functions? Anyone not have all real numbers for domain? No. So parabolas or absolute value functions all have a domain of all real numbers. Range, however, will switch. So let's talk about range here. What's the range for this one? Greater than or equal to 0. What's the range for A here? Negative 5. Here, y is, okay. This 0 and this negative 5 and this 4, where does it show up? It's the y coordinate of the vertex. Do you see that? So the range for the parabolas is always going to be connected to the y coordinate of the vertex. Okay? From the vertex, the range is always going to go either above or below. It's always going to be either y is greater than or equal to the range, the vertex, or less than. So when is it greater than or equal to, and when is it less than or equal to?
Less than or equal to.
When it's facing down, when there is a reflection. So how does that look in the equation? When there is a reflection, there is a negative. So now, if I were to give you any random function that you haven't seen before, so y equals, would you be able to figure out the domain and range? What's the domain? All real numbers. What's the range? Y is greater than or equal to, because it's positive, -2. Okay, so how did we figure that out? Because the vertex is going to be -4, -2. Okay? It's positive. So taking the positive means it's greater than or equal to. Taking this, that's the value. You see that? So if you were walking down the street and on a billboard you saw some random equation of a parabola, of a quadratic equation, you would be able to figure out the domain and range like this, right? Yes. Okay, what about this one? Okay, what's domain?
All the numbers.
What's range?
Less than or equal to 1, 3, 0.
0. Because where does this parabola move? To the right, but does it move vertically?
No.
No. So it's 0. Isn't that cool? Super cool. That's a skill that you could like totally brag about now. Right? Okay. Now, let's write some equations then. Okay. To write equations of graphs, you need to first figure out the vertex. What's the vertex here? 5, -3. Okay. The vertex is going to be H and K. Okay? Now, you are going to plug these into these formulas basically. When you have an absolute value, the A is basically the slope. Okay? When you have an absolute value. So one point is going to be your vertex. Why pick another one, right? And now pick a second point. Let's pick this one. Okay? What's the slope here? I go up 2 over 1. So slope is 2. So my A value is 2. Is it positive or negative? Positive because it faces up, right? So now y is 2 absolute value x minus h, which is 5, absolute value minus 3. No, because the k is added, right? It's the same sign. Okay, why don't we do, let's do the other absolute value, d. What's the vertex? -4 and -3. And that's your h and k. Okay, so now let's pick another point. What other point can we pick? Maybe this one here. What's the slope? Down 1 over 3. So what's the slope? -1 over 3. Okay, so y is negative 1 over 3 x plus or minus 4? Plus 4 plus or minus 3? Minus 3. Good. Now, this would be full credit. This would not be full credit. Why? Because there is no y, right? Because here it says to write the equation, but this is not an equation. It's just a expression. So you could either do f of x equals or y equals. Yeah, is that your question? Okay. Next, let's do the parabolas. For the parabolas, there is another skill I need you to learn, so we're going to do this a little bit differently. You again have to figure out the vertex. In this case, it's negative 3 comma 4. And always label this as your h and k. Now, we're going to pick another point on the parabola, but make sure it's a corner point, right? So you don't have like halves or fractions or anything.
Doing on the x-axis.
The x-axis, it's still like it's still kind of like a half. So, but if I do this one, what is that? It's negative 1 comma 2, right? Now, I label this x and y, okay? What I want to do is figure out using this, what is my a value? So the formula is y equals a x minus h squared plus k. Now, I have h and k, I have x and y, I plug them all in here. So y is 2 equals a, x is what? Negative 1 minus h, so that's plus 3 squared plus k is plus 4. Okay, do you see that? So xy here, hk here. Now I can solve this and get a. So 2 equals a times 2 squared plus 4. 2 equals 4a plus 4. So what's a? Negative a half. Okay? So we go back here. F of x equals negative a half. This time I'm going to just plug in h and k. X plus 3 plus 4. Okay? Oh, squared. Okay? All right, questions? All right, let's do another one. Here. What's the vertex? Okay. Oh, you know what? This time, this point, the intercept is on a corner, so I'm going to pick that. 5 comma 0. And always label, right? This is xy, this is hk. Okay. So, y equals, I'm sorry, not y. Well, let me write the formula first. A x minus h squared plus k. So what's y? Negative 6 equals a, what goes in the parentheses? What number minus what number?
No, 5. That was negative 6.
Oh no, see, that's why I told you guys to label it. Oh my gosh. Okay. 0 equals, thank you, 5 minus 7 squared minus 6. Yeah?
Wow.
So 0 equals a times negative 2 squared minus 6. 6 equals 4a. So a is 3 over 2. Does it make sense that a came out to be positive? Yeah, right? So f of x equals what? Tell me. 3 over 2 times x minus 7 squared. Minus 6. Good. Okay? Isn't that fun? All right, so with that, the homework to this is actually a worksheet.